Great. Well, thank you very much for asking me here to talk to you today. So in this presentation, I'm going to talk about our recently started ESRC-funded project, Britain's First Demographic Transition and Integrated Geography. Before I do anything else, I'm going to introduce my team, because this is very much a joint effort, both the project and also this presentation. And what I'm going to talk about and show is often the direct results of my team's hard labour. So Kevin Schurer plays a vital role in reworking and further improving the individual census material originally made available from the ICEM project, which are the main data source that we're using in this new project. Ailey Garrett has been my colleague for a very long time and has a deep knowledge of census data, and particularly of that relating to Scotland. For this project, she's based in Edinburgh with Lee Williamson, and together they provide important links with the Digitising Scotland project, which will be another very important source of data for us. Hannah Yardler has worked on our previous project and assists us all and performs a lot of the substantive demographic analysis, as well as a number of other things. Max Satchell is our GIS expert, and Sophie Arulinanthem is our project administrator and outreach coordinator. So I'm here to talk about this project, Britain's First Demographic Transition and Integrated Geography. What this project aims to do is to re-examine the population history of Great Britain. And what we really want to do is to tell the story not of 2 or 3 separate countries, Scotland, England, Wales, but as a spectrum of experiences over time and space. So we focus on the late 19th century for 2 real reasons. One of them is that this is a really, really interesting period in demographic history. It's when the first demographic transition started to take place. So on the left here, I've got a little graph of crude birth and crude death rates showing that this period from about 1870 to 1911, or it actually carried on a bit longer, but 1870 to 1900 is when really fertility and mortality started their seminal falls from high to low levels. We know already quite a lot about this period. National trends are well established. Mortality decline started in childhood and early adulthood. Infant mortality lagged behind a bit, particularly in urban industrial areas. The fall in fertility was led by the middle classes, but quickly spread throughout society. Urban growth was fueled by movement from the countryside to the city, but there was also considerable migration overseas, particularly from Scotland, and also some in-migration to offset that. However, there's still a lot of things we don't know. We don't know exactly how fertility fell and how that was connected to individual women's choices and so on. We don't know how all sorts of the whole regimes, fertility, mortality, migration, marriage, and so on, how they were really connected both in time or space. So the other reason for focusing on the late 19th century is because we can make use of individual level census data. So this has relatively recently been made available in a systematic and digitized format through the ICEM project. A lot of what we already know has been derived from census data, but mostly from published census reports. So I'm talking about the work of people like Bob Woods, who wrote mostly about England and Wales, Mike Anderson, who's written about England and Wales, but also particularly about Scotland in his recent book, Scotland's Populations. And they've also, of course, used the Registrar General's annual and decennial publications, which relate to vital statistics. But published research can really only get you so far. Researchers are limited to the tables, age groups, geographical units, and so on, which were published at the time. And this can really constrain the questions asked and the scales on which they can be interrogated. Of course, other people have used individual level census data, but this tends to be for just small places or a limited number of years. So individual level census data, particularly when it's for the whole country or several whole countries, can is much more powerful and can allow us to ask a whole range of different questions. Our project, we've called it integrated. This is a key word for us. And this is because we want to look at Scotland and England and Wales together. Most other studies have looked at these really in isolation or just drawn comparisons between the individual countries, high-level comparisons between Scotland and England and Wales, rather than looking at them all together as a spectrum of places within them. So we wonder maybe if the border between England and Scotland is being drawn is slightly artificial, and that there may be differences between parts of Scotland and or similarities between different parts of Scotland and the adjacent parts of England, or maybe there are similarities between areas in Scotland and England which have similar economic structures but maybe more distant from each other. So Mike Anderson in Scotland's Populations, his recent book, has made some such comparisons. He's argued, for example, that Scotland's demographic experience was significantly influenced by opportunities in England as well as in Scotland, selectively drawing migrants and generating divergence. So there were strong links between the demographic systems across the British Isles, and we want to take this further in our project. One thing to note is that this project builds on our previous project, which was also funded by the ESRC, which was called an Atlas of Victorian Fertility Decline. So the previous project used census data for England and Wales to interrogate the fertility decline in those places. We didn't include Scotland in this earlier research project because we needed to draw in single-year mortality figures, which at that point weren't available for the right geographic units, but because we have now digitising, Scotland has produced this data, which enables us to do this. So what sort of research questions are we going to be asking in this project? So as already mentioned, we aim to explore the variety and interconnection of demographic systems and regimes across Britain. We want to look at the different ways in which different areas experience the first demographic transition and the roles played by economic, occupational, cultural, and perhaps also linguistic factors. Economic integration and regional specialisation help to shape the demographic processes of migration, nuptiality, fertility and migration across all three nations. And this suggests that they really should be considered together, but also to look at individual variation within the whole group of countries. But on the other hand, differences in welfare systems, in legal systems, employment practices, land tenure, religion and language and so on, might have generated differences between, for example, Scotland and England and Wales. So one of the questions we want to ask is to examine the extent to which there were demographic continuities between these three countries, or were there distinct Scottish and Welsh demographic systems. So we'll do this, we'll look at this by looking at demographic indicators, fertility, mortality, and so on, the role of place, class and occupation in the spread of new ideas, through the analysis of small area statistics and social groups within small areas. We also want to focus on migration, which is the poor relation of demography. It's often not really looked at. We want to measure migration a little bit better and also consider its effect on other demographic indicators and how they're measured. So the fact that migrants are often selected for particular characteristics can affect demographic rates and characteristics in both migrant sending and migrant receiving areas. And finally, we want to look at household structures and how they vary across Great Britain during the demographic transition, and to what extent they're connected to changing demographic processes. So I'll just briefly talk about the data that we're using. So I've mentioned the census data. So this project and our previous project are hinged around ICEM, the Integrated Census Microdata, which was another ESRC-funded project led by Kevin Shurer and Eddie Higgs. And this was a collaboration between Find My Past, and it took Find My Past census data and cleaned it and coded it for academic use. Now, when we used the data for our previous project for England and Wales, we discovered that it needed further enhancement to generate robust results for the analyses we were undertaking. So we needed to reallocate a considerable number of records to their correct place of enumeration and to improve the coding of some key variables and relationships within families, particularly. So we've already done this for England and Wales, but we need, part of the current project is to do these further enhancements for Scotland, and I'll talk about some of these issues a little bit later. We're also going to be using the decennial mortality data published by the Registrar General for England and Wales, which was so well used by Bob Woods and Nicola Shelton in the Atlas of Victorian Mortality. That's quite easy to bring in and use. We didn't include much mortality data in our previous project because it was mainly about fertility, but this new project will look at mortality in more detail. But we'll also use Scottish mortality data from Digitising Scotland. And because Digitising Scotland has digitised individual level mortality data, we can reshape it into the geographic units, the age groups, and the causes of death that we'd like to use in order to compare with England and Wales. The other significant bit of data that we're using is the data which leads to a geographic information system. So we've already produced a GIS shapefiles for registration sub-districts for England and Wales as a part of our previous project. And as part of this project, we're producing a GIS for registration districts of Scotland. Now, this is heavily based on work, some great work already done by Corinne Ruffley for Mike Anderson's book, which is a parish GIS. And I'll talk in a little bit about how we're adapting that and the challenges that raises for adapting it to a registration district GIS. So a little bit about methods. We're aiming to produce a lot of demographic indicators from the census. So the census, of course, doesn't easily yield fertility data, but we're using the own child method of fertility estimation to generate age-specific fertility rates and total fertility rates. Basically, this uses mothers and children in household units with some manipulation to generate estimates of fertility. If we impute children who are no longer living with their parents into households because they're dead or living elsewhere, we can also generate measures like parity progression ratios and birth intervals. And then finally, we can use the numbers of young children living with their mothers in regression analyses of the determinants of fertility. For nuptiality, marriage, we're going to be calculating singular mean ages of marriage and celibacy rates, and the mortality data will be age, sex, cause specific mortality rates. In terms of migration, we can look at lifetime migration using birthplaces in the census, and we can also look at calculate measures such as age at leaving home from household data. But we'll also use cohort depletion to generate age-specific migration rates, net age-specific migration rates for different areas. And then altogether, we're going to apply spatial statistical methods and a variety of different statistical and regression techniques to analyze these further. So the next set of slides is going to illustrate some of the things the team has been grappling with in the first 6 months of the project. We started at the beginning of April. So we've been doing this project in lockdown with weekly Zoom meetings. And after that, I'm going to show you a few results from our previous project to whet your appetite for some of the treasures which we hope will emerge in the next couple of years. So first of all, I want to talk about registration district mapping. And this set of slides has been prepared by Max Satchell, who's been doing all our GIS work, as I mentioned previously. So it's perhaps surprising that while registration districts were actually quite well defined in one sense by description of the areas that they contained, their boundaries don't seem to have been consistently mapped until after the Second World War. However, there is quite a large overlap between registration districts and civil parishes, in that that quite a large number of their boundaries are the same. And this makes it much easier. So there are many registration districts that which were coterminous with civil parishes, which we can basically use Corinne Ruffley's parish boundaries to represent the registration district boundaries. However, there's a significant minority of registration districts where we have to create boundaries, so about 100 registration districts in total. And Max is doing that, and he's also creating something called a polyline file, which, as I understand it, contains the metadata for the source and reliability of each boundary segment. So I'm going to give you some examples here. So the dull in this title of this slide doesn't refer to how interesting the contents are, but it refers to the parish of Dull in Perthshire. So there's a parish of Dull and a registration district of Dull, but they don't overlap all that much. So the parish of Dull overlapped with 4 registration districts, and we don't know the boundaries for most of these 4 registration districts. The parish also had detached parts, so some bits within other registration districts, and it also contained some parts of registration district, parts of parishes and registration districts from other places, parts of other parishes within it. So it's a very complicated, geographically very complicated area. So Max's approach has been to geolocate the census address data, so we know which addresses are in which registration district, and then use contemporary Ordnance Survey maps to estimate the likely location of boundaries. So here's an example. So this is a part of the parish of Dull, and the dots on here are the geolocated addresses, and they've been coloured according to the registration district in which they occur. So the yellow dots refer to the addresses in the registration district of Dull, and the red dots refer to addresses in the registration district of Aberfeldy. Now, these were both in the parish of Dull. So, but we can see that actually the River Tay, forms a good boundary. It divides the yellow dots from the red dots really well, and we know that rivers were often used as boundaries, and in this case, we can see that they were used as parish boundaries for some of the other parish divisions between Dull and other parishes. So this suggests that actually this is a really good guess for where the registration boundary did occur. So we can say that this is probably the right boundary. Another example is one of the other boundaries of Dull registration district, and this is between Dull and Foss registration districts. This is a bit different because and addresses are really very little help here, because this was a really very sparsely populated area. It's an area of high ground, as you can see from all these closely spaced contour lines. So no one really lived here, and it's very difficult to know where the registration district boundary might have been thought to have gone. You may think actually that this makes very little difference, and in some ways it doesn't make a difference. It doesn't really affect which registration district people are going to be allocated into. However, decisions like this can have a very large effect on the area of different boundaries, different registration districts, and therefore a large effect on population density. So we do want to produce realistic feeling boundaries. So Max's approach here is to note that in areas like this, registration boundaries of parishes or registration districts often follow the watershed or the ridge line, and so he's used this elevation data set, which shows the contour lines, to create a sort of pseudo boundary here shown in the sort of purple dashed line along the ridge line. He's less secure about this, so he's called it a possible boundary, but basically it's a boundary that we're going to use. And we think it's probably quite a realistic boundary. One of the other sorts of things that we've done regarding registration districts, one of the other issues is that they vary dramatically in population size. Some of them are incredibly large with hundreds of thousands of people in them, and others have populations with only a few hundred people, which is really too small for meaningful analysis. So we need to amalgamate some small registration districts in terms of population size. That's relatively easy. We can just match them up with a neighbour and join them together. It's much more difficult to subdivide large population registration districts with large populations. So these large ones are all in city areas. And I'm going to show you an example of how Max is going about subdividing Glasgow. So in 1891, Glasgow had a population of over 600,000, and we are going to use the sub-registration, the registration sub-districts. It had 14 of those. Now these again weren't mapped, and the registration sub-districts tend to change a lot from census year to census year. So we're going to use the 1891 boundaries and then reconfigure the census into those boundaries using addresses and also the mortality data as well for the other years. So basically, to do this, the first step is to link census addresses to a GIS of modern road names and then use some other sources to tidy this up. So here's the first part of what we get when we match modern road names and 19th century census addresses. So we can see here that here's sub-district number 3, Denniston, and we can see that most of these, most of the roads identified here are in a well-defined area, which we can then use to generate the boundaries of this sub-district, and then we can tidy this up. Of course, there are some places which are in the wrong place, but that's probably because a road has been demolished from within this area and another road with a similar name has been built elsewhere. But those are quite easy to deal with. So this is basically part of the way we're dealing with this. An unintended or a benefit of this is that really we're ending up with geolocated addresses within cities, and this means that actually we will be able to do some street level analysis either as part of this project or on into the future. We didn't write this into our project, so it's a sort of exciting unintended benefit. Moving on from the GIS, other ongoing preparation tasks, data preparation tasks, include things like coding birthplaces. Many people were asked to provide their parish and county of birth, but many people gave different sorts of places which were at a sub-parish unit, and we're actually coding places to a sub-parish unit because that will give us more specificity in where people have come from and allow more sophisticated analyses. Another task is checking variables and checking consistency between the responses at individual levels on a sort of in a systematic way, checking that individuals have combinations of age, relationship, sex, and so on, which all make sense. But also, we also want to examine distributions. So here's an age distribution of the Scottish population over time. So the light blue lines indicate 1851, and that the green line is 1901. And we can see that this age distribution looks as we might expect from a 19th century census. There's considerable age heaping, but this reduces over time, which is an entirely plausible thing. We can see at the early age end of the age distribution, the fact that the proportions of people in the youngest age group declining, particularly in 1891 and 1901. This is indicative of the beginning, of the start of the fertility decline, which is starting at this time. Just out of interest, here I show this is the same graph I showed on the previous slide for Scotland, and some comparisons with England and Wales. And we can see that actually Scotland has much higher levels of age heaping than England and Wales, and that England has a more pronounced fertility decline from early on, although that's followed quite soon by Scotland. So there are some particular indications of what might be interesting to look at. Of course, these do hide considerable variation within places. So this is from a previous project that Ailey and I did on the town of Kilmarnock in Kilmarnock in Scotland and the Isle of Skye. And we can see that Kilmarnock has very little age heaping, whereas age heaping is really pronounced in Skye, so that we do have to bear in mind the considerable variation within Scotland, and there will be similar variation within England and Wales as well. Skye is interesting because the age distribution indicates not only this age heaping, but we've got this big lump of young people, particularly from the age of about 5 to the age of about 15, and then a deficit of young adults. And this indicates that young adults were leaving the island, but perhaps bringing their children back or leaving their children with the children's grandparents to be looked after while the young people themselves sought work elsewhere. One of the other tasks is to look at household relationships and to make sure that those are captured as accurately as possible. This is very important, of course, for the analysis of household and family forms, and particularly for our analyses of fertility. In recent censuses, relationships are captured using a matrix. So each person is asked to state their relationship to each of the previously listed people within the household. So here in the top right is the census relationship matrix from the 2011 census. This was just the example that was provided in the census form. Of course, in the actual form, there were more options available. And this provides a possibility of identifying exactly how people are related to all of the other people in the census. Now, this wasn't the case in 19th century censuses, which only asked the relationship to the head of the family. This is largely unproblematic for the vast majority of households, because in Britain at the time, most households were quite simple nuclear households. However, you do have to assume that the wife of the head, and heads are usually male, the wife of the head is the mother of the head's children as well. And that of course isn't always the case. So we are unable to identify stepmothers in the census. If the head has been widowed and then remarries, some of the children may not belong to the wife, but we can't really identify that in the census. Grandchildren are also a particular problem. So here, this is an example from Kilmarnock again. James Hunter and Dick Hunter, these are grandchildren. They're aged 3 and 3 months. We don't know whether they belong to the unmarried son, the unmarried daughter who are in the household, or to an unmarried daughter who isn't in the household, or to a married son who isn't in the household. So there may be relationships. These children might have a mother or a father in the household, but we can't tell that from the relationship information. And this is a drawback of using historic censuses that we just have to bear in mind when we do the analysis. One thing which we have noted as Kevin Shaw is doing this work on the households, that he's noted as he's coming to do this recoding, is that Scotland shows some evidence of common law unions. So we have a significant number of, or a small but significant number of households where we have people who are coded the head, people who are coded wife, but unmarried. Here, some of them, the heads are married, and the supposition is that they're married to somebody else, and the wife is unmarried. So the question is what to do about these. We're choosing to take this at face value, and that these are common law unions, and so the wife is the mother of the children in the household. It could, of course, be some sort of mistake in transcription or recording, but we do know that common law unions were much more common in Scotland than elsewhere in the British Isles, and so we'd like to capture this in our coding. Of course, we won't be able to capture many such unions because a lot of people who were in common law unions didn't record this in the census in ways that we can capture in the census. And here's an example. So again, this is Kilmarnock. So in 1871, we can see John Stevenson with four children and a servant. And there's no reason to think that the servant is anything but a servant. In fact, because for Kilmarnock, we have had access to the civil registration, we can see that Elizabeth Lang, the servant, had 13 children between 1866 and 1877. That's a lot of children in a short space of time, but it did include 2 sets of twins. None of the children had a father in the birth, allocated in the birth register, but all of those who survived to census date were in the census listed as John Stevenson's children. So these start with Mary and Barbara. The 2 older children must have been from John Stevenson's actual wife. In 1881, Elizabeth appears 3rd in the census, but still with a relationship servant. So she comes after John, who's not her own child, but before those children who are her own children. But we have no real reason to suppose that they are her children. It's not until 1901, 30 years after 1871, that we can see in the census any indication that these children are Elizabeth Lang's children, because William and Barbara, in that year appear with Elizabeth's surname, although Elizabeth herself wasn't present in the census in that household. So unfortunately, in our current project, we wouldn't be able to link Elizabeth and John as a part of a cohabiting couple. So we do need to realise that the census hides certain relationships as we undertake our analysis. So in the last part of this project, this talk, I'm going to just give you a few examples of results from our previous project. These are mostly to do with fertility, because our project was really located around fertility, but they'll give you some idea of some of the things that we're hoping to do with the Scottish data and the comparisons that we can make across place and time. So here are just total fertility rates using the own child method from each census. There are issues with the 1871 census, which means we have a gap there, but each line basically is the total fertility rates derived from a different census, each coloured line. And we can see that fertility declined from the mid-1870s, or from 1881 until the end of our period in 1911, from about 4.5 children per woman to just under 3. And that's about half of the total, or over half of the decline in fertility during the first demographic transition. One of the things we're interested in when we look at fertility decline is how fertility falls according to age of woman and number of children. So the received wisdom is that fertility fell when people developed a target number of children, so parity-specific control. When we think about what parity-specific control will look at when we think about age-specific fertility rates, so here's a sort of schematic diagram here. So we've got fertility rates by age here, and this is the sort of normal pattern by age. When people start to reduce their fertility, have a target number of children, the thought is that they tend to have those children when they're young, and then they stop when they've reached their target number. And this produces a hollowing out of the age-specific fertility curve. What we can see when we look at age-specific fertility rates, these are marital age-specific fertility rates. So, so we don't see a rise in the early ages because it's just within marriage, but we don't see a hollowing out in the older ages. So here each line is, the faintest lines are 1851 and the darkest lines are 1911. So we don't see any real evidence of parity-specific control here, not even for the highest social classes. So here these are social class 1, which is professionals and administrators and so on. Social class 5 as unskilled workers, and then we've got 3 special groups, textile workers, miners and agricultural labourers, that the Registrar General wanted to single out because they had unusual fertility. If we look at parity progression ratios, that's an even better way of telling whether there is any parity-specific control. So parity progression ratios basically show the proportion of people who have no children who go on to have one child. So 90% of children who get married have at least one child. Of people who have one child, about 90% or just over 90% go on to have a second child, and so on. These three coloured lines, solid coloured lines at the top, show parity progression ratios for the three 5-year periods leading up to the 1911 census. And we saw that that was when quite a lot of fertility decline happened, but actually we see very little change in parity progression ratios. So approximately the same number of children who reached 2 children were going on to have a third. This didn't change very much over time. And this, where there were declines, it was similar at different parities. And this is in big contrast to what happened after the Second World War. These are the parity progression ratios from 1951 until early 1970s, when most people who got married went on to have one child. Most people who had one child went on to have a second child, but then there was a big drop, and far fewer people who had 2 children went on to have a third child. So here we see a strong establishment of a 2-child norm, which wasn't there in the early part of the fertility transition, which was really characterized by non-parity specific fertility decline. And that's a new story which hasn't really been told before. One of the other things we've looked at is migration and the spread of fertility decline. So some theories suggest that fertility decline may be spread by new ideas being transmitted by migrants from one place to another, by the diffusion of ideas throughout society. So the supposition is that people who've migrated are likely to be bringing fertility, to have lower fertility, and to be spreading that towards other people. So so what we see here is some estimates of the effect of both social class and or the effect of distance migrated since birth for women for a variety of different years, 1851 at the top to 1911, on their fertility, and we've shown for 4 different occupational or social class groups. And we can see that before the demographic transition, 1851 to 1881, people who'd migrated furthest had much lower fertility. And this was particularly the case for unskilled workers and other groups which had also high fertility, like miners. However, during the transition, this low fertility among migrants really disappeared, and in fact, even among textile workers, it reversed in direction. So migrants had higher fertility. So we feel that actually a better explanation for this is that high and early fertility was in many ways a hindrance to migration, and having children young really stopped people migrating rather than being something which spread, which was a vehicle for spreading new ideas. But that could also have been to some extent the case. So one of the final things I want to tell you about is about premarital sexual activity. So in pre-industrial England and Wales, extramarital births and premarital pregnancies varied inversely with age at marriage. So basically, as the age at marriage increased, people get married later, people were less likely to become premaritally pregnant. So that's sort of in this bit of the graph, less likely to become premaritally pregnant, and less likely to have a child without being married. And as ages at marriage decreased, people became more likely to be prenuptially pregnant and to have a child outside marriage. This may seem counterintuitive because it's not really how things work today, where rates of illegitimacy vary inversely with marriage rates, or vary together with age at marriage. But it can be explained by something called the courtship intensity hypothesis proposed by Peter Laslett. And this states that when prospects for marriage were good, premarital sexual activity was more intense. There were more premarital conceptions, many of which precipitated a marriage, but those which didn't precipitate a marriage led to an illegitimate birth, and so there was so illegitimacy also rose. So, of course, we can't look at premarital sexual activity directly using the census. We have estimates of illegitimacy from for particular areas from the Registrar General's reports, but we have developed a way of estimating prenuptial pregnancy from census records. It's too complicated to tell you how right now, so you'll just have to take my word for it. But we have produced estimates of prenuptial pregnancy over time for different types of place. So here we've divided up England and Wales into areas which we've characterised agriculture, mining, and so on. And we've looked at those. We've here graphed levels of prenuptial pregnancy against illegitimacy and the cingulate mean age at marriage for women. And we can see that in accordance with the courtship intensity hypothesis, these seem to vary together. So as prenuptial pregnancy decreases, so does illegitimacy as well. But there are quite different relationships between prenuptial pregnancy, so the acceptability of premarital sex in many ways, and marriage regimes. So we have, in mining areas, we have high levels of prenuptial pregnancy and low ages at marriage for women, but we have similarly high levels of prenuptial pregnancy in agricultural areas, but much higher ages at marriage. And this is interesting. So we think this is, related to different regimes to do with the acceptability of premarital sex and how that relates to marriage markets and so on. And it's interesting because we know that illegitimacy was much higher in Scotland, and particularly in parts of Scotland. And this was linked to forms of agricultural labour, particularly for women. So we're really looking forward to investigating the relationships between age at marriage, illegitimacy, premarital sexual activity, and so on across Scotland, and comparing this with all the different areas in England and Wales. And finally, this is my final slide. Part of our previous project was to create an outreach website, which is called Populations Past, and this maps a whole variety of different demographic and socioeconomic indicators, which can be explored for areas of the country. You can zoom in and zoom out and look at how these have been calculated and so on. And part of our current project will, of course, be adding Scotland to this website. So we're really excited about doing this and hope to have that visible in due course, although don't hold your breath because it will take us a little while to get it there. So thank you very much.